Okay, so this is the video for my physical science class 1.4 Kinematic Equations. And so I'm just going to be solving the homework with you guys just to give you a good, really review of how to solve problems. Because this is important. This builds like your base for pretty much a good part of the year, which is why it's so important for you guys to understand how to do these questions and how to process them. So we're gonna do the first question, right? So we're gonna do the first question here. Open like a tab. Do the first question. So do the first one. So the speed of a wagon increases from 2.5 meters per second. I'm gonna underline this. So the speed of a wagon increases from 2.5 meters per second to 11.5 meters per second. So the first thing you need to do here is you need to figure out what your information is. Right? We need to figure out what our information here is. And so we're going to use 5 variables, right? We're going to use VF, VI. We're going to use A, T, or D. And hopefully you watched the video that preceding this, right? For the 1.4 class video, where VF means final velocity. Right? Final velocity. Or let me just write it all out. Final velocity, initial velocity, and A means acceleration, so A is acceleration. T means time. Now my handwriting is not the best, but hopefully you can read. And D means displacement or distance. Right, displacement or okay? So we're going to put these numbers, we're going to identify at least 3 pieces of information from the problem. So again, let me underline this. So speed of wagon increases from 2.5 meters per second to 11.5 meters per second. So this is certain phrasing, right? And there are 2 ways to figure out what the information here is. The first thing that's pretty much guaranteed to give you the answer is meters per second. You see the unit for the numbers. If you see meters per second, that's actually how you measure speed. So let's go to our cheat sheet here. Go to our cheat sheet. So number 1, units. If you see this unit, you can assume it is a certain quantity. So if you see meters per second, you can assume that is a speed or velocity unit. Right? So, and then the phrasing also matters, right? Because it says the speed of the wagon increases from this number to this number. So we're going to look at our cheat sheet again. Look at our phrasing. Increases / decreases the speed / velocity from number to number. Number to number. So your first number here is your initial velocity, and your second number here is your final velocity. So that's an easy way to tell. So our first number is initial. So we're going to put that at VI is equal to that. Put our final is 11.5 meters per second. We're going to continue reading our problem, and then I come across 3 seconds. Well, what is that? What does seconds measure? Seconds measures time. Time is 3 seconds. As it accelerates uniformly down a hill, again, you can look at your cheat sheet, right? Your cheat sheet, seconds is time. Seconds is time. And continue. What is the magnitude of acceleration of the wagon during this 3-second interval? Right, so what is the magnitude of the acceleration? So A is what? Alright, so we're going to use a formula. So now we need to pick a formula. And which formula has everything we want, has all our knowns and what we want to solve for. Right, so let's go through this list. Let's go through these 3 formulas. And you can find these formulas, you don't know, you can find these formulas in your reference table. So we're going to go to your reference table, click this, all the way down to this last page, right, page 6, where you see mechanics, and their formulas are over here, right? These three formulas that I'm highlighting, these are your formulas. So we're going to use these formulas. Again, if you don't know where it is, it's under class materials, right? Class materials right here. So we're going to go back to our problem. So let's see which formula we need to use. Let's look at the bottom one. Do we have VF? Yep, we got VF. Do we have VI? Yep, we got VI. Do we have A? We're solving for A, so sure. Do we have D? Well, we don't have D, which means we're not going to solve for it. We're not going to use the formula to solve for the question. Let's look at the second one. Do we have D? Nope. So we're definitely not solving using this formula to solve for the question. Let's look at the first one. VF. We have VF? Yep. VI? Yep. A? Well, we're solving for A. T? We have T. So we're going to use this formula to solve for A. And you might be asking me this question, well, how do I solve for A if A is not by itself? Well, let's think about it. Let's do this. Let's use the formula. VF is equal to VI plus AT. VF is 11.5. VI is 2.5. A is A. T is T. A3. So now I want A by itself, right? We want to solve for A, which means we have to get A by itself. To get A by itself, we're going to take things that are farthest away from A and get rid of it. The farthest thing from A right now on this side is 2.5. So we're going to get rid of 2.5 here. And how we're going to do that, we're going to do the opposite operation of what's here. Since this is 2.5 plus A3, we're going to subtract 2.5. Right? We're going to get rid of things that's farthest away from A first. So this gives you 9. So A times 3 gives you 3A. And now how do we get A by itself? Well, this is a multiplication operation between 3 and A. This is 3 times A. To get rid of this 3, we have to divide by 3. We have to do the opposite. And so we get this. Alright, so the answer here is C. Feel free to pause before I move on, because I am going to move on. Number 2. A truck initially traveling at a speed of this number increases its speed, so it increases its speed at a constant rate of 2.4 meters per second for 3.2 seconds. Now the first one's okay, right? So initially traveling at this speed, well, you're given context clues, right? You're given initially and traveling at a speed of this. You're also given the units, right? Meters per second is a speed measurement. So you can safely assume that this is your initial speed. Now, it says increases speed at a constant rate of 2.4 meters per second squared. You see this unit here, meters per second squared. Meters per second squared is a unit for acceleration, right? Is a unit for acceleration. And also that's what constant rate means, right? Constant rate is acceleration. So we're going to put A of 2.4 meters per second squared. And then you see the seconds, which means it's a time measurement. All right. And then the question is asking you, what is your total distance traveled? So what is D? So now we need to figure out a formula to use. So look at the first formula. Do we use the first formula? Do we have VF? Nope. Don't have VF. Do we have D here? Yeah, we got D. Do we have VI? Yeah, we got VI. Do we have T? Yeah, we got T. Do we have A? Yep, we got A. Do we have T? We got T. And when I say we have D, it means we're solving for it as well. So we're going to use a second formula. Okay, so we're going to use a second formula. So D is equal to VI T plus 1/2 AT squared. D is equal to VI, which is 22. T is 3.2. 1/2 2.4. 3.2 squared. Right, so 22 times 3.2 gives you, I gotta get a calculator now. So we have 22 times 3.2 gives me 70.4. 3.2 squared, so we're gonna do 1/2 4. What's 3.2 squared? 3.2 squared gives me 10.24. 10.24. Let's simplify this now. Let's 70.4 times this entire thing. So 1/2 times 2.4 gives you 1.2. 1.2 times 10.24. I'll just do this entire. So let's do plus 1/2 times 2.4 gives you 1.2 times 10.24. So this gives me 12.288. And this gives me 82.688. And we round it and we get D. All right, move on. Pause it again if you want to copy down things. All right. Number 3, the speed of a car is increased uniformly from 20 meters per second to 30 meters per second. Again, this is a phrasing. You're going from one speed to another. Also, you see the units. You see the units, meters per second. That's a speed measurement. So you're going from one speed to another. So your initial speed is this. Your final speed is that. And then say seconds, right? So 1 second. And then you're solving for acceleration, right? So we're going to go back to our formulas. So we're going to use, well, let's go for our formulas. Well, do we have VF? Yep, we got VF. Do we have VI? Yep. Do we have A, or are we solving for it? Yeah, we are solving for A. And do we have T? Yep, we got T. So we're going to use that formula. So we're going to do VF is equal to VI plus AT. VF is 30. VI is 20 plus A, 1. So 30 is equal to 20. 1 times anything is itself. But to get rid of this 20 because it's added to A, so we subtract 20. So we have 10 is equal to A. I'm just going to put the unit here, meters per second squared. And that's the answer for 3, C. Feel free to pause before I move on. Exit this out. So the question begins with, what is your final speed? So what is VF? Of an object that starts from rest. So this is a very specific phrasing. Starts from rest. Right? Starts from rest. Again, look at your cheat sheet. Starting from rest means your initial velocity is 0. So you can just say my VI is 0. Accelerates uniformly at 4 meters per second squared. Again, you see the unit, meters per second squared. You also see the context. Accelerates at. So accelerates at 4 meters per second squared. So you know that's acceleration if you look at your cheat sheet. Is over a distance of 32 meters. All right. So which formula are we going to use? Right, we're going to use this one. I'm going to stop going to that like specific formulas. Now I'm just going to go ahead. You guys can figure it out for yourself. If you want to practice, maybe you want to pause in between these videos to see if you're right. Feel free to do that always. Feel free to pause before I go into the answer or pick a formula or pick a note, right? If you want to test yourself, feel free to pause. So VF squared, we use this formula, by the way, because it has VF, right? Because we're solving for VF. We have VI, we have A, and we have D. VI is 0 plus 2, A is 4, D is 32. 2 times 4 is 8. Okay, and then 8 times 32 is 256. We want VF by itself. We have the square root. We get 16 meters per second. So that's B. All right. Now we move on to 5. A race car traveling at 10 meters per second accelerates. So this is your speed, right? It sees 10 meters per second. Because you see meters per second. So you know that's speed or velocity. Accelerates at 1.5 meters per second squared. You know that's acceleration because you see meters per second squared. You see accelerates. While traveling a distance of 600 meters. The final speed of the race car is approximately what? We're going to use this formula. Right? Because that has everything you need. You have VF, VI, A, and D. So VF squared is equal to 10 squared plus 2, 1.5, D, 600. VF squared is equal to 100 plus 2 times 1.5 gives you 3. And so now we had 3 times 600 plus 1800. 100 plus 1800 gives you 1900. We're going to take the square root of that, gives us 44. All right, the answer is D here. Number 6, again, if you want to pause before I write down everything we know, feel free to. Right, so if you want to test yourself, see if you're correct. So an object traveling at the initial speed of this number, so we know that's VI, accelerates uniformly at this number, so accelerates at 2 meters per second squared. You know that's acceleration because it is 2 meters per second squared. In the direction of its motion for a distance of 21 meters. It's saying what is the final speed of this object. All right. We're going to use this formula. So we're just going to plug things in. 4 squared plus 2, D21. VF squared is equal to 4 squared is 16. 4 times 4 gives you, 2 times 2 gives you 4. 1. 4 times 21 gives you 84. 16 plus 84 gives you 100. Then we square root. And that's 10. All right. Okay. Again, if you want to pause the video before I come up with the answers, feel free to. Initially traveling east with a speed of this. Accelerate uniformly at 10 meters per second squared, because it's acceleration because it says 10 meters per second squared for 3 seconds. covers the total distance of what? Alright, so again, if you want to pause before I come up with the formula, feel free to pause. See if you can try and guess the formula yourself. So this formula has everything we need. It has D, has VI, has T, has A, and has T. VI is 2, T is 3, plus 1/2, A is 10, and then T squared is 3 squared. 2 times 3 gives you 6, plus 1/2 times 10. 3 squared gives you 9. We do 6 plus 1/2 times 10 gives you 5. So 5 times 9 gives you 45. And then D gives us 51. Right? And so the answer is A. Feel free to pause again. Alright, last question. Again, feel free to pause before I come up with a known, see if you can guess for yourself. Accelerates uniformly from 3 meters per second east. You're accelerating from that speed. Right? Even though it says acceleration, you're accelerating from this speed, not at this speed. I mean, at this number, you're accelerating from this number. You'll also see per second east. I'm sorry, what is square here? Per second. And then to this other number, right? That's your final speed in 1 second. So t is 1 second. So what's the magnitude of acceleration? Okay, I'm going to use this formula. Vf is 8, Vi is 3, plus A1 minus 3 minus 3, 5. 1 times anything is itself. And this is our answer. Okay, hopefully you guys learned something.